So this pre-calculus lesson is your intro to radian and degree measures and the unit circle. I hope that you will take your time going through this video and pause it and rewind it as much and as often as you need. Okay, angles can be measured in degrees and radians. If you'll look at these pictures to the side, you can see that every angle has an initial side. Initial means where it starts, and a terminal side. Terminal means where it stops. You cannot just have the two sides of an angle. You have to have this sweeping arrow in the middle to define the angle. Because if I have the same initial side here and terminal side here, I could be talking about that angle. So it's very important to draw this arc with the arrow on it to define your variable, or to define your angle, sorry. Positive angles, okay, so your initial side is always going to be the x-axis pointed to the right. Positive angles sweep up and over counterclockwise. Negative angles sweep down clockwise. So if we look at this little symbol right there is alpha. It's a Greek letter, and this right here is not B, it's beta, just like a bee with a tail. These are all capital Greek letters. So this initial side and this terminal side technically defines an infinite number of angles. They have let alpha be this angle, and beta is this angle. Alpha would be a positive angle. Beta would be a negative angle. Alpha and beta are called coterminal angles for this particular example because they begin and they end at the same point, but they're not the same angle. They both have the same initial side, and they both have the same terminal side. So they are coterminal because they share a terminal side, but they're not the same angle. If you remember from back from basic geometry, half a lap or a semicircle is going to be 180 degrees. So alpha is over 180 degrees, and beta is just over 90 degrees. So they're and it's negative. So they're very different angles, but they are called coterminal because they share a terminal side. Okay, now look at this next example, and I can draw it a little bit bigger. Okay, so for alpha, this is my initial side, this is my terminal side, and there's alpha. Small angle, probably around 45 degrees. And then if we look at angle beta looks to start on the same initial side, but he loops all the way around and then hits the terminal side. So beta is going to be over 180 degrees. If I go another half lap, so that's a full circle, that's 360 degrees, which we'll talk about here in a second. So, and he's even more than that, so he's probably pushing 400 degrees. So alpha is probably 45 degrees, give or take, and beta is 400 degrees, give or take. So again, two very different angles, but they are coterminal because they begin and end at the same point, but they are different angles. Pi is not a variable. Pi is a constant. It's 3.14 and a whole bunch of other decimals. It is radians, is its unit of measurement. Pi is 3.14. Okay, so if we looked at this diagram right here, again, this is where we always start. Pi takes you all the way over. So pi is 3.14 radians. So 3 radians is going to be just shy of that. So what would this be? Well, if from here to here is pi, then from here to here would be pi over 2, or half of a pi. And if you take 3.14 and divide it by 2, you get 1 and some change. So 2 radians is going to be just past half a pi, and 1 radian is going to be short of half a pi. This is 0. 4 radians, of course, is going to be over pi, because pi is 3.14. This distance, straight down, is 1.5. So he's 3 pi over 2, which is, if you go decimal with that and plug in a 3.14 right here, you get 4 and some change. So this is 4 and some change. So 5 radians would be just beyond it. 4 radians would be shy of it. And then if I go all the way around, I'm out of colors, all the way around, well, if half a lap is pi, then a whole lap all the way around is 2 pi. Well, pi is 3.14, so 2 pi is 6 and some change. So 6 radians is just shy of that. Okay, now I refer to, and we're going to use these a lot, I refer to these as, I didn't put, as your north, south, east, west. They are sort of your cardinal directions. So I want you to know that this is always your initial side. I want you to know that half a lap is pi. I want you to know that a whole lap is 2 pi. I want you to know that due north is pi over 2, because that's half of this guy. I want you to know that due south is 3 pi over 2, because that's 1.5 pi's. And you can see we've got 1.5 of another one. I don't want you to say it's 1.5 pi. I want you to call it 3 pi over 2. That's going to help you later, as in the next class. Okay, so to summarize, I need you to know, like super quick, right off the top of your head, I need you to know that this is always your initial side, that pi is half a lap, 2 pi is a whole lap. Okay? If half a lap is pi, I need you to know that due north is half a pi, so pi over 2. And I need you to know that due south is going to be a pi and a half, so that's 3 pi over 2. I need you to know your north, south, east, west super quick off the top of your head, like really fast. Okay? So now we have these angles that have been measured in radians because we see the pi. And I just want to sketch about where they are. I do not want you to go decimals on this. I want you to go fractions. I want you to think, and you're going to hear me ask, how many pi's is that? And you're always remembering that 1 pi is there, half a pi is there, 1.5 pi is there, and 2 pi is all the way around. So if I look at number 1, I have 3/4 of a pi. Well, again, I know that a whole pi is half a lap. So 3/4, if you think of this, and you probably already know where it is, but I want you to think about the details. I want you to think of this pie literally like a piece of pie divided into 4 pieces. But this pie is only half of a pie. Your mom made a pie, your dad ate half of it. So there's half a pie left. You're going to divide it into 4 pieces. 1, 2, 3, 4. Well, I have 3/4 of the pie. I get to eat 3/4 of the pie. So my angle is going to start there, and it's going to end here, and then I have to sweep my arrow from beginning to end. And that's how you sketch the angle. So without all this other mess on it, this is what it would look like. That's it. That's what I want. Now number 2 is negative, which means we swing down, not up and over, we swing down. And this is 1/3, okay? So now start to think of this as our pi, and I want 1/3 of it. Well, if I were to divide this into 3 pieces, 1, 2, 3. Well, I only get one piece, only have 1/3. So there's my starting side. There's my ending side. And there's my angle. That's negative, so I'm swinging down, pi over 3. When you get to number 3 and it's 11 pi over 4, the first thing I'm going to ask is how many pi's is that? We'll divide up. 4 goes into 11 2 times, so 2 full pi's. 4 goes into 11 up to 8, so there are 3 left over. So I have 2 3/4 pi. Okay, watch carefully. Start on my initial side. Now I have 2 full pi's. That's not 2 full laps. Remember, pi is half a lap. So that's 1 pi. Then there's 2 pi. Now I need 3/4 of the next pi. Remember, pi is only half a lap. So I want 3/4 of the next pi. And you have to have the snail looking thing because you have to show me I had 2 full pi's and then I had 3/4 of another pi. So here we go again. 1, 2, and then 3/4 of the next one. Okay, let's look at number 4. So how many pi's is that? Well, that divides up. That goes 2 1/2 pi's. Okay, so here I go. Starting here. There's 1. There's 2. And there's half of the next one. So it ends due north. Again, 1 pi, 2 pi, and then half of the next pi. So what you really need to not think, a pi does not equal a circle. That's false. Pi equals half a circle. Okay, number 5. Okay, how many pi's is that? Well, let's see. That goes up. Don't lose your negative because that tells you which way to swing. 3 1/3 pi. So here I start. I got to swing down, and I got to go 3 1/3. Okay, you ready? 1, 2, 3. That's 3 full pi's. Now I need to go 1/3. Okay, so think of this is my next pi, and I only want 1/3 of it. So I would stop right there because this right here is 1/3 of that pi. Okay, so if I erase all this and make it look normal, starting side, initial side, negative, so I swing down. 1, 2, 3, 1/3. There you go. And you got to have the arrow and you got to have the loops because all of that shows the direction and how many you got. Okay, this is the bulk of what this lesson is, this finding coterminal angles. So if I have 13 pi over 6, I want a positive and a negative coterminal angle. So I'm giving you 13 pi over 6, which is 2 1/6 pi. That's the angle I'm giving you. You can't give me back that angle. You have to give me one positive and one negative coterminal angle with that one. Okay? So I'm going to baby graph it. So 2 1/6. Okay, so here I start. 1, 2, and 1/6. Like 1/6 of a piece of pie is tiny. So there is my angle, the angle I'm giving you. You now have to give me a positive and a negative coterminal angle. So that means we have to start at the same place. We have to end at the same place. But you can't give me 13 pi over 6. You can't give me the angle I gave you. Well, for positive, can't I just go from here to here? Like, that's not the original angle, but I am starting and stopping at the same place. It is positive, so the question is, how much is that? Well, if this one was 1, 2, and a 6th, then this piece right here is the 6th. So that is the positive coterminal angle with 13 pi over 6. Okay, now I got to do the negative angle. Well, the negative means I got to swing down, which means I got to start here, swing down, and end there. Because we have to start and stop at the same place. So this is, kind of looks like Pac-Man. This is what I want. I just got to figure out how much that is. Now remember, you're negative. Okay, well, how much is this? Well, half a circle is pi. Remember, we're negative. So I have a negative pi plus, all right, that gets me to here. Now I got to figure out how much this is. Well, guys, think about your fractions. If this is 1/6, then how much is this? That would be 5/6. Remember, it's negative. Now add these two pieces together. Well, you need a common denominator. I don't want -1 and 5/6. So common denominator would be a 6, so he needs a 6 over 6. So that would give me a -11 pi over 6. Okay? And again, I could explain that again, but all you have to do is hit pause and rewind a little bit and listen to number 1 again to make sure it's sinking in. Because after a while, I'm going to start picking up the pace. So if you need to pause at any time, please feel free to do so. Okay, number 2. 3 pi over 4. Well, how many pi's is that? Well, that's not even 1 pi. 3 pi over 4, that's 3/4 of a pi. Okay, so if I take pi, which is half a circle, and I go 3/4, that's going to put me there. So that is the original angle. The original angle, which means you can't give me that back. You have to give me a positive and a negative coterminal that's different from that. So for the positive angle, I cannot start here and stop there because that would be 3 pi over 4. What I have to do is start here, keep going, and then hit the terminal side. Remember, we have to start and stop at the same place. I don't get to change where I stop. We have to stop on that terminal side. So now I just have to figure out how big this angle is. Well, that's pi. That's another pi. So we're at 2 pi right now. That puts me here. Now I got to get to here. Well, isn't that the same thing as the red line? And that was 3 pi over 4. Okay, common denominator, so multiply the first one by 4 over 4, so that would be 8/4. And then add that together, that would give me 11 pi over 4. That's your positive coterminal angle. Okay, now I'm going to erase all the blue, and I'm going to put the red back so we can do our negative coterminal angle. Okay, 3 pi over 4. Okay, so now I need the negative coterminal angle, which means I still start here, I still end here. But I got to swing down to get there. Okay, and that is not the original angle. The original angle is the red line. I'm the blue line. So I just got to figure out how much this is. Remember, it's negative. So this would be negative pi. And then how much would this be? Well, if the red line is 3/4, then this would be 1/4. But remember, it's negative. And then if I multiply him by 4 over 4, that would be negative 5 pi over 4. Remember, when you add fractions, you have to have a common denominator. You combine the tops, but you do not touch your denominator. So there's your negative. Okay, number 3. Negative 2 pi over 3, swinging down, negative 2/3. Well, there's 1/3. there would be 2/3. So I'm to here, negative 2/3. That's my original angle. Positive angle, I have to go from the initial side to the terminal side, but I have to sweep up and over. That's not the original angle. That's not the red line, so I'm good with that. I just have to add up my parts. That's a pi. The red line is 2/3, then what's left right here would be 1/3. Multiply him by 3/3 and add, that would be 4 pi over 3. There's my positive angle. Now my negative angle. The red line just went straight from here to here. So my negative angle, I have to loop and then hit the terminal side. Okay, well from here to here is negative pi, and then another negative pi, so I'm at negative 2 pi. Now I got to do this. Well, how much was that? Well, that was my negative 2/3. Common denominator, so that would be negative 6/3, and then add, that'd be a negative 8 pi over 3. Number 4, 5 pi over 2 is 2.5 pi. 2.5. 1, 2.5. Due north. Okay? Now, you can tell the original angle looped. Now make sure you understand what I mean by looped. Like it did a whole lap, like a racetrack. It went all the way around. So if the original angle loops, that means I don't have to loop. All I have to do is get from my initial side to my terminal side. Because the blue and the red are two totally different angles. The red is huge. It's 2.5 pi. How much is the blue? Well, remember, all the way over here is pi. I'm going halfway. So it's pi over 2. The negative angle needs to start here and end here, but I need to swoop negative. Okay, well this is a negative pi, and this is a negative pi over 2, a half of a pi. Common denominator, negative 3 pi over 2. Positive, negative. Negative 5 pi over 4 would be negative 1 1/4. Again, don't lose your negative. If you do, you're going to lose which way you're swinging. Okay, so negative 1 1/4 of another one. There we are. Positive angle, all I have to do is get from the initial side to the terminal side, swinging up and over. Blue line and red line are blue arc and red arc are two totally different angles, so we're good. So I just have to figure out how much this is. Well, if this was a 1/4, then this is going to be 3/4. So 3 pi over 4. Now for the negative angle, look at the red. It did not loop. So when I go negative, when I swing down, I can't just stop right there. That is the exact angle of the red arc. I have to keep going and come back around and hit the red line. I have to loop. I have to take a lap. Okay, so now let's add up everything that's green. And feel free to do this in colored pencils or make separate graphs, whatever you need to do. So this is going to be negative pi. This is going to be another negative pi. This is going to be another negative pi. Or you could have just gone 1, 2, 3. Either way, same thing. Then I just need to figure out this distance. Well, that is my 1/4. So minus pi over 4. Common denominator. 1, 2, 3, that's 12, and one more would make a negative 13 pi over 4. Positive, negative. You should be starting to get the gist of this. It's all about the little baby graph that you're going to draw, and it's all about adding the parts together. Okay, number 6, how many pi's is this? 6 goes into 17 3 times? Nope. 5, nope. twice. Yeah, I can do that. So negative 2, and it goes up to 12, so there's 5 left over. All right. Let me get my red. So negative, so swing down. 1, 2. Now 5, 6. That's almost a whole nother pi. It just leaves a 6 left. So there he is. There's my original angle. Okay, positive angle, all I have to do is get from here to here, swinging up and over. I don't have to loop. All is good. So that's going to be pi plus, and what's this little guy? Well, that's your leftover from the 5, 6, so that's going to be 1, 6. So pi over 6. Little common denominator, 7 pi over 6. Now, for the negative, this one's neat. If I, the original angle, looped all the way around, then you, the coterminal angle, don't have to. All you have to do is that, because look, the original was the red. Do you see how it took a lap? And the green just has to go from here to here. It's going to be much smaller than negative 17 pi over 6. So all I have to do is figure out this. Well, this, remember, was just a 6 short of a whole pi. This is just your 5, 6 part. Remember, you did the 1, 2, and then 5, 6. So from here to here is just a negative 5 pi over 6. Okay, number 7. I love nice round problems like this. This one's fun. Ready? Let's see, red. Okay, here we go. Got to go 7 pi's. 1, 2, 3, 4, 5, 6, 7. Now here's a fun question. Did I loop? Yes, I looped. I looped 1,000 times. Absolutely, I looped. Well, that's great, because that means when you do your part, you don't have to loop. All I have to do is get from here to here. Ready? Bloop. That's it. So what is half a lap? Well, half a lap is pi. Okay, now for the negative one, all I have to do is get from here to here and swing negative. Bloop. There he is. So it's negative half a lap. Well, it's negative pi. Number 8. Negative 5 pi over 2. Again, don't lose your negative. That would be negative 2.5 pi. So negative, swing down, 1, 2.5 of another one. There he is. Ends up on south. Okay, so positive, I have to get from here to here. Swing it up and over. There he is. So that's going to be a pi, and then a half of a pi, 2 over 2, so that gives me 3 pi over 2, which should be one of those ones that you memorize. If I'm going to go from starting to due south, that's 3 pi over 2. Now the negative one is really easy, so here's the question. Did I, the original angle, the angle that's in red, did I loop? Did I take a lap? Yes. So that means when you do yours, you don't have to take a lap. All you have to do is get from here to here and not be the same angle as me. Well, I'm the red angle. This thing is huge. It's negative 5 pi over 2. It's negative 2.5. You can be the little guy. You can be this guy. So what's that? Well, that's negative pi over 2. Negative because it's swinging down, and it's half of a pi. Number 9. Okay, how many pi's is this? Let's see. 6 into 23, it's almost 4, but it's not quite. 3, and that gets us to 18, so there's 5 left over. Okay. So here we go. 1, 2, 3, and then 5, 6, which is almost a whole nother pi. So there I am. Now, did I, the original angle, loop? Yes. Looks like a snail. So all you have to do is get from here to here, but you've got to be positive first, so you've got to do that. Okay, so how much is that? Well, that's pi. And then how much was this? Well, that was the 5 pi over 6. 6 over 6, so 11 pi over 6. Now the negative 1, all I have to do is get from here to here and go negative. Well, that's the leftover part from the 5 pi over 6, so that's easy. That's negative pi over 6. That's the 1/6 that's left. Okay, picking up the pace just a little bit. 5 pi over 3 is 1 2/3 pi. And again, feel free to pause it in between each problem and write or catch up or watch it again. Do what you need to do. Okay, so the original angle, 1 2/3. 1 1/3, 2/3. 1 2/3. Now, I did not lap or loop, which means when you do your positive and you go from here to here, you can't do that because that blue line and that red line are the same angle. You have to keep going. You have to loop because I didn't loop. If I don't loop, you have to loop. But if I loop, you don't have to loop. Okay, now I got to add all my loops. All right, here we go. 1 pi, 2 pi, 3 full pi's. Plus, what's that? Well, that's the 2/3 part. So that'd be 9/3 plus 2/3, so 11 pi over 3. Okay, then if we go negative, I got to get from here to here. All I got to do is that right there. Well, that's the 1/3 that's left from the 2/3, so negative pi over 3. Okay, let's see. This is negative 4½ pi. So let's see. 1, 2, 3, 4½ There he is, due south. Now, did I loop? Oh, heck yeah, absolutely, several times. So all you have to do is get from here to here. Oh, well, sorry, I did the negative one first. Okay, so that's going to be a negative pi over 2. Sorry about that. Now to do the positive one, you got to do that. So that's pi, and that's half of a pi. That'll be 2 over 2, so that's 3 pi over 2. Positive, negative.
Teachers, please call this interruption this time. I need all the girls.
Okay, number 12. Negative 3/4. Negative 3/4 of a pi. Negative, swing down, 3/4. Okay, I did not lap. But look, the positive one, I have to go from here to here. So they're not the same line. So I'm good there. So that would be 1 pi plus, and then that would be the 4th that was left over. So 4/4 plus 1/4 would give me 5/4 pi. Now, negative, I did not loop. Look at that little red line, which means when you swing down, you have to loop. Okay, so let's add 1, 2 full pi's. So negative 2 plus a negative. All right, what's that? Well, that's the same as this, which is the negative 3/4. So he'd be negative 8/4, so negative 11 pi over 4. Okay, negative 7 pi over 4 would be negative 1 3/4. So negative 1 3/4 of the next one. So positive, all I got to do is get from here to here. Boom. How much is that? Well, that's the 4th that was left over. So pi over 4. Now for the negative one, look at that little red line. It did not loop, which means you can't do that because that red line and the green line are the same angle. You have to keep going and lap and come back and hit it. So now let's just count the green. 1, 2, 3 full pi's. So negative 3 pi. And then this Well, that is the -3/4. So -12/4 and -3/4 would be -15 pi over 4. I don't want you to have to use your calculator to add these fractions. I want you to be super comfortable with common denominators and adding fractions. So practice that. Don't be in denial about having to learn that if you're not really good with it yet. So -2 1/4. -2, 1, 2 1/4. Boom. Okay, positive. I got to get from there to there. Okay, so 1, and then that. Okay, well, if this was a 4th, then this is 3/4. That's 4/4, so 7 pi over 4. And then negative. All right, now look at the red. Did I loop? Yes, absolutely. Make sure you can see it. Here's the loop. I did a loop, and then I hit the angle. So I don't have to. All I have to do is that. Well, that's the 1/4. So negative pi over 4. Done. And then with number 15, I just want to make sure that you can still do this with degrees. Just to make sure we're super clear, if we come back to this basic unit circle right here, this is 0 degrees when you start. 180 degrees is all the way over. 90 degrees is due north. You know that. All the way around is 360 degrees, and this due south guy is 270 degrees. So it's adding 90 every time. So 4 times 90 gives me the 360. I forgot what the last one was, but I think it was like 120. So 120 degrees would be somewhere in here, somewhere. Okay, but I need you to know that due north is 90 all the way over, so a pi is 180 degrees. A whole lap around is 360, so that's 2 pi. And then a pi and a half, or 3 pi over 2, is 270 degrees. I just need you to know your north, south, east, west. So this was 120. So when I graph him, I know that this is 180 degrees, and I know this is 90. I don't care exactly where he is. I just need to know that he's in here somewhere. There's 120. I know he's 60 shy of 180, and I know he's 30 over 90. Okay, so for the positive coterminal angle, I can't just do that because that's what the original angle was. I have to lap and come back around. Okay, well, what's a whole lap? But now change in your mind from radians, change to degrees. A whole lap in radians is 2 pi, but a whole lap in degrees is 360 degrees. So that gets me to here, and now I've got to get to here. Well, that's just what the original angle was, so that's the 120. So that makes us 480 degrees. The negative one, I've got to get from here to here, but I've got to swing negative. Half a lap is 180, negative. Then this piece right here, now we were at 120 degrees, and we said earlier that that was 60 shy of 180. So I know that distance right there is 60. It's going to be negative. And then I add and get negative 240. Okay, then we've got to talk about angles being complementary and supplementary. This last little bit of the notes is super easy, so you've survived the worst. This is important, but not near as difficult to process. Okay, two positive angles are complementary if their sum is pi over 2, and supplementary if their sum is pi. Now, hopefully you remember this from Math 3 or Math 2. Complementary adds to 90 degrees, and supplementary adds to 180 degrees. We are now transferring this into radian measure. So 90 degrees is your due north, which is pi over 2, and 180 degrees is due west, which is pi. Really easy to do it with degrees in your head. Like, let's look at 62. or B, sorry. Find the complementary and supplementary angles for the following angles. Well, 62 degrees. So if you were going to set this up mathematically, and this is what you do in your head, but you'd say 62 plus what gives me 90 degrees. And then you would subtract 62. Well, in your head, you're really just trying to find how much more does 62 need to get to 90? How shy of 90 degrees is it? So that would be 28 degrees, because I know that 28 and 62 is 90. Now that's the complement. The supplement would be 62 degrees plus x equals 180 degrees. So then 180 minus 62 is 118 degrees. So that's this guy's complement, and that's his supplement. Adding to 90 degrees and adding to 180 degrees. Well, so for A and C, we're just changing gears, and we're just changing our brain to think radians. But you set it up the same way. That's my point. Watch this. Pi over 9 plus something. Now for complement, we're 90 degrees. That's due north. Okay? What's the radians for due north? It's pi over 2. So pi over 9 plus something has got to give me pi over 2. Well, subtract your pi over 9. All right, now common denominator. Going to be an 18. So negative 2 pi over 18 and a 9 pi over 18. And subtracting it, 7 pi over 18. Process is the same. And if you can do all that in your head, knock yourself out. But I highly recommend writing out your work. And that's just for complement. Now we got to do supplement. Well, supplement, it's pi over 9 plus something equals, in supplement, it's 180 degrees. What is that in radians? Well, that's pi. That's half a lap. This one's much easier. What's 1 minus 1/9? Well, it'd be 8/9. If you want to do the whole common denominator thing, you can. That one won't change. And that would be 9 over 9, because that gives you 1. And 9 over 9 minus 1 over 9 gives you 8 over 9. So complement, supplement. Okay, now C is just a tiny bit different. 4 pi over 7. If you're on your toes, you're going to realize that that's more than a half. That's more than a half of pi. So guys, I'm already over north. Well, an angle does not have a complement if you have to subtract from it to get to your destination. So if I want to get to pi over 2 and I'm already overshot it, then he does not have a complement. If you're not on your toes and you don't see that, this is what it's going to look like when you set it up. 4 pi over 7 plus something should equal pi over 2. Complement is due north. Subtract your 4 pi over 7. Go get a common denominator, which would be 14. That would be 7. 7 to 14 is 2, so that would be a negative 8. And when you subtract, do you see that you get a negative? That means the original angle already overshot my destination, so I'm having to be negative to backtrack it. I don't want negative complements or supplements. If you've already overshot it, then you just say it doesn't exist. The complement does not exist. Now his supplement will, because he's not over here at pi yet. So 4 pi over 7 plus something equals pi. If you think about a piece of a pie, it should be real simple to know that that's 3 pi over 7. If you need to subtract, that'd be 7/7 minus 4/7, which gives me 3/7. So he has a supplement, but he does not have a complement. So complements, the goal is to get to here. 90 degrees if you're in degrees, pi over 2 if you're in radians. Supplement, 180 degrees if you're in degrees, and pi if you're in radians. Complement, supplement. Okay, and the last thing we have to do is converting from radians to degrees and degrees to radians. I don't know if any of you have taken chemistry, but when you have chemistry, you have units of measurement. And a lot of times they'll give you, I don't know, miles per hour and they want feet per second. Or they'll give you liters per something and they want gallons. So you've got to be willing to change your units of measurement. Okay, I want you to look at the ratio that we use. Pi over 180 or 180 over pi. That number is not out of thin air. This is why we choose that. This is pi, which is also 180 degrees. So technically this ratio is a 1. Pi equals 180 degrees, but pi is in radians and 180 is in degrees. It'd be the same thing if I used 60 seconds and 1 minute. They are equivalent. I'm just changing my units of measurement. When you do this, here's how you're going to remember which one goes, because one of them has pi over 180 and the other one has 180 over pi. What you want should go on the top. If I want radians, if I'm converting to radians, I want pi on top, radians on top. I want to get rid of degrees, so I'm going to put my degrees on the bottom so that they cancel with whatever the original problem is. If I have radians, I want radians on the bottom, so my pi's will cancel. And I want to end up in degrees, so I want degrees on top. If I had 5 minutes and I wanted to convert it to seconds, would I put minutes on the top or on the bottom? I would put it on the bottom because I want my minutes to cancel and I want it to leave me with seconds. Now what's the ratio here? 60 seconds, 1 minute. So I know that that's 300 seconds in 5 minutes. So what you want to cancel goes on the bottom. What you want to keep goes on the top. So I don't want you to feel like you have to memorize this. The reason we use 180 in pi is because this one is pi over 2 and 90. That's not an awesome ratio. Neither is this one. That would be 3 pi over 2 and 270. Now we could use this one. This one's really nice, but watch. 2 pi over 360. Guys, doesn't that reduce to the pi over 180? That's why we use that pi over 180, because it's the cleanest of the north, south, east, west. Okay, so let's use it. 135 degrees. I have degrees, so degrees are going in the bottom. I want radians, so radians are going in the top. Pi is 180 degrees. That's my ratio. So now when I multiply, my degrees cancel. And I have 135 pi over 180. Well, you can reduce that. If you're not good with reducing stuff, leave the pi out. Just do 135 divided by 180, get a decimal, and then go math fraction. It's going to tell you it's 3/4. But when you do that, please don't forget that the pi is still in your answer. Pi is not a unit of measurement. Pi is 3.14. Like, that's a value. So if you take pi out of your answer, you're taking a 3.14. You're dividing a 3.14 out. So just make sure you keep your pi in there. 540 degrees. I want to convert it to radians, so degrees go on the bottom. Our ratio is pi and 180. Degrees cancel. I know I can cross a 0 out. So 54 pi over 18, you can do 54 divided by 18 on your calculator, and you get just a nice round 3. So 3 pi. 540 degrees is 3 pi, so it would be 1, 2, 3 pi. There's 540 degrees. Negative 270, again, if you're on your toes, you shouldn't have to do anything for this one. Negative 270. 90, 180, 270. So what is that in radians? Well, 3/4 of a lap is 1.5 pi's, and it's negative. Now, if you don't catch that yet, degrees on the bottom, pi's on top. Degrees cancel. Don't lose your negative. You can also cross out a 0. Negative 27 pi over 18 reduces to negative 3 pi over 2. Okay, last thing, let's go the other way. So now I have radians, see the pi? I have radians, and I want degrees. So I put degrees on top, radians on the bottom. Because now look what cancels. And this would be negative 180 degrees over 2, which is negative 90 degrees. Now stop and think. That's negative pi over 2. Doesn't that make sense? Negative pi over 2. That's a negative 90 degrees. It's negative half of a pi. 9 pi over 2. I want degrees. Degrees go on top. Pi's cancel. I can also reduce by 2. So 810 degrees. You could do that in your calculator if you wanted to also. Okay, now number 22. I know you don't see a pi, but you see the word radians. So this is 2 radians. Now be super clear on this. That does not mean 2 pi. 2 pi is 6 and some change radians because pi is 3.14. So 2 pi would be 6.28. This is 2 radians, 2 pure, cold, hard radians. Pi is 3.14 radians. So this is a little bit less than pi, but it's just 2 pure radians. So when I take the 2, I still want degrees. But I have no pi to cancel with my 2. So when I do this on my calculator, I'm going to do 2 times 180, and then I'm going to divide it by pi. Make sure you keep the degree symbol on your answer because that is your unit of measurement. Okay, I know this was a lot to digest. So go back, rewatch, rewind, work through them one more time, do whatever it is you need to do before you dive into the homework. When you start the homework, make sure that you're checking them as you go. And make sure you're being really clear about the directions. Take time and read the directions. And if you have questions, come see me during Smart Breakfast.